Life on Earth thrives under a delicate balance of weather systems. From gentle rains to powerful storms, our skies are constantly in motion. But above the clouds, beyond the Earth's atmosphere, lies another kind of weather. One not written in rain or wind, but in plasma and light. This is solar weather. Streams of charged particles, solar winds, and explosive flares that ripple across the solar system, shaping the space environment for every planet. Solar weather begins with solar flares. Sudden flashes of energy when the sun's magnetic field snaps and reconnects. In just minutes, a flare can release the energy of billions of hydrogen bombs, showering Earth with radiation that disrupts radio signals. Sometimes the sun hurls out massive clouds of plasma called coronal mass ejections, or CMEs. These giant eruptions travel millions of kilometers per hour. When they collide with the Earth's magnetic field, they trigger geomagnetic storms. Then there are solar particle events, bursts of high energy protons racing through space at nearly the speed of light. Earth's magnetic shields blocks most of them, but near the poles they can slip in, disturb the ionosphere, and even pose dangers to astronauts beyond the Earth's protection. All of this follows the sun's natural heartbeat, the solar cycle. Every 11 years, the sun's magnetic field flips and the storms grow stronger during solar maximum. During solar maximum, the sun becomes restless. Giant magnetic loops twist and store immense energy. When they snap, the sun unleashes brilliant flares, flashes of light, and radiation that races towards Earth in just minutes. Along them, enormous clouds of charged plasma called coronal mass ejections are hurled into space, traveling millions of miles per hour. These storms can grow larger than planets, carrying billions of tons of charged particles wrapped in powerful magnetic fields. As they expand, they reshape the space environment around them, moving through solar system with immense force and energy. Mercury, with almost no magnetic shield, is struck directly, its surface exposed to the relentless force of the solar storm. No wonder there is no life here. It's basically a cosmic frying pan. Venus, wrapped in thick clouds but still lacking a strong magnetic field, loses parts of its upper atmosphere as the storm sweeps by. Even all that gas can't hide it from the sun's fury. And then the storm continues on its journey heading straight towards Earth. After leaving Venus, the solar storm races through space, invisible bodyguard million magnetic field just to protect the planet heading straight for Earth. Streams of high energy particles from the sun push against this barrier, twisting the magnetic lines under pressure. On the sunlit side, the field compresses while currents guide particles towards the poles. On the night side, the magnetosphere stretches into a long tail, channeling particles away from the planet. Far in the thin atmosphere, oxygen and nitrogen ignite in waves of green and violet, draping the sky with the aurora, Earth's luminous response to the raging solar storm. Though the solar storm is a force of chaos, its collision with the Earth's magnetic shield creates a spectacle of stunning beauty. The auroras ripple and shimmer like curtains of light, painting the sky with colors that dance and flow. It's a paradox of nature, a reminder that even powerful, potentially harmful forces can give rise to moments of breathtaking wonder, turning a storm into a cosmic light show visible from the ground. But while the auroras dazzle our eyes, the storm's charged particles are not just a spectacle. They ripple through our technology, affecting satellites, GPS, and power systems across the globe. High above Earth, satellites carrying GPS and communication signals are the first to feel the storm's effects. In the ionosphere, where charged particles collect, plasma density becomes turbulent. The storm creates rippling waves that scatter radio signals and confuse GPS accuracy. In the cockpit of an aircraft, GPS screen begins to jump and drift unpredictably, making precise navigation a challenge. Ships at sea also experience shifting GPS signals as routes appear to wander off course. Even on ground, our everyday devices can feel the storm. We drift away from the Earth, its swirling storms and glowing auroras shrinking into a fragile jewel in the darkness. The sun and planets recede in quiet orbits tracing paths through the void. Beyond lies the Milky Way, a river of sparkling stars, luminous nebula, and invisible giants spinning in endless harmony. Galaxies stretch across the cosmos, clusters of light and shadow entwined in a timeless ballet. Pulsars flash, black holes lurk, and untold worlds drift in silence between stars. With every layer we uncover, the universe deepens, reminding us that we've seen but a single page in an endless chronicle. Beyond that page lies the unknown, vast, waiting, and full of promise. The story of the cosmos is far from over. In truth, the adventure has only just begun.